Good morning, friends of class 12th. See, before we learn the topic of potentiometer, we have to go through a very small example. This example is only for your understanding. Okay, so try to understand this example because this will build the concept of understanding of potentiometer. Okay, so here I have a small circuit, a battery of 10 volt and resistance to total 5 resistance of 2 ohms. So the total resistance in the circuit is what? The total resistance in the circuit is 10 ohms. Total resistance is 10 ohms. Total EMF, you know what is EMF? EMF in the circuit is 10 volt. Okay. So what is current equals to? Current in the circuit will be equal to 10 by 10, that is equals to 1 ampere. Okay. Now, what current flows in the circuit? It is 1 ampere. What is current through this? 1 ampere, 1 ampere, 1 ampere, 1 ampere, 1 ampere and so on. Okay. Now, what is the use of this circuit? See, if I have, you have to be very careful in understanding this example. I have a cell and the EMF of cell I do not know. But if I want to know, if I want to measure the EMF of this cell, what I will have to do? See, if I connect the positive terminal to this point, negative terminal to this point, and in between I put a galvanometer. Now what is a galvanometer? It is basically a device which which actually tells whether current is flowing or not flowing. Okay, if the current is flowing, this will show you a small deflection, and if current is not flowing, it will simply, the needle will be at rest. Okay, so I am connecting one terminal here, another terminal here, and suppose that the current in the galvanometer is 0. If the current in galvanometer is 0, it means that the potential on this side of galvanometer and on this side of galvanometer is same. Okay, suppose instead of galvanometer there is any device, there are 2 points, point X and point Y, and if I connect them through a wire, okay, there is some potential at this point, say V, and some potential at this point, say V dash. But when these points are connected with the wire, the current in it is equals to 0. If the current is 0, it means that there is no potential difference. What is the basic cause of electric current? Potential difference. Okay, if current is not there, that means what is potential difference? There is no potential difference. That means potential difference V minus V dash is equals to 0. It means that V is equals to V dash. Okay, in Hindi I will try to say दोनों जगह का potential same है, इसीलिए current flow नहीं हो रहा. In the same way, the potential on this side of galvanometer, above the galvanometer and below the galvanometer is equal. So no current is flowing. Now if no current is flowing, what is this? This is open circuit. What is measured in open circuit? It is the EMF that is measured in open circuit. So now you can say, what is the EMF of this cell? This EMF of this cell is equal to the potential difference on the other side. That means potential difference over here. How do you calculate potential difference over here? E equals to V equals to IR. What is current? 1. What is resistance? It's 2. So what is the potential difference? 2 volt. And what is the EMF of this cell? It's 2 volts. Okay. Now, does not happen. I am connecting the cell like this and the current is not equal to 0. There is some value of current, maybe 1 ampere or 0.1 ampere, but current is not equal to 0. What I will do, I will remove the connection from this part and connect it to this part. And now, after doing this connection, current in the galvanometer, you can think of this as an ammeter also. Okay, so current in the meter is equals to 0. Okay, what does this mean? Potential on this side of galvanometer, potential on this side of galvanometer are same. What is potential on this side of galvanometer? It is equals to epsilon. What is the potential difference on the other side of the galvanometer? It is V, which is equals to I into R. What is the current flowing in this part? It is 1 ampere. What is the resistance from here to here? It is 4. So what is the EMF of this cell? It is equals to 4 volt. Okay. Now if suppose this also does not happen, connect it here, but still the current is not equal to 0, what you will do? Connect it to this part and now the current becomes equals to 0. Very simple. What will be the EMF? It is equal to the potential difference between these two terminals. What is the potential difference between these two terminals? IR, current is 1, resistance is 6, it is 6 volt. Got it? This is how we actually measure the EMF of cells experimentally. Okay? But this is not always advisable to join these kind of circuits because all the resistance are of 2 ohms. Okay, so there can be a cell of EMF 1.5 volt also. If the EMF of cell is 1.5 volt, it is not going to show 0 at this terminal also. What should we do? Make all these as 1 ohm, 1 ohm, 1 ohm, 1 ohm. Okay, and make this as equals to 6 ohm. What is EMF? 10. What is total resistance? 6, 7, 8, 9, 10. What is the total resistance? Total resistance is 10 ohm. Okay, now this is the circuit. Connecting galvanometer over here, other terminal to the cell, and now suppose that the current becomes 0. If the current becomes 0, that means EMF, which is equal to potential difference, which is equals to I into R. What is current? Current is 1. What is resistance? Resistance is also 1. What is it? It is 1 volt. That means EMF of the cell is equal to 1 volt. Okay, this was the conceptual problem. Now, what is potentiometer? See, potentiometer is this circuit only, but it is a bit modified version of this. Instead of all these resistance, we have one simple wire. Call the wire as AB or X wire, call it AB. What is this? This is a simple high resistance wire. It could be made up of nichrome or tungsten or manganese or any other alloy. Why alloy? Because alloys have more resistance compared to pure metals. Okay, now we have to measure the EMF of a cell. This is the EMF of a cell. This is epsilon. This circuit is known as the primary circuit. Okay, and whatever we connect at the bottom of this wire AB is known as the secondary circuit. In books, you will find a different diagram of potentiometer, but I am not drawing that because in examination you will be facing this type of, whether it's board examination or competitive examination, the type of circuits of potentiometer which they give is of this type. Okay, so this is primary cell in the primary circuit. Epsilon is the EMF, resistances R, unknown EMF epsilon 1. Here we have this galvanometer and the connection of galvanometer on this wire. This particular connection is known by the name of jockey. Jockey is not something what you are always thinking of. Jockey is also known as the horse rider. Okay. So where is the horse? This is the horse, this is the rider. So this connection is known as a jockey connection. What is to be done is this. You have to move the jockey. What is this? My finger is the jockey. You have to move this on this wire up to a point. Say here, if the jockey is in contact with this point, and at this point the current in galvanometer becomes equal to 0. It means that, first of all, it means that it is in open condition, and what is measured in open condition? EMF gets measured in open condition. Now if this is in open condition, potential on this side of meter is equal to potential on the other side of meter. What is potential on this side? It is equals to EMF. What is potential on the other side? It is the potential difference between points AJ. What is potential difference between AJ? It is current into resistance. What is resistance? It is rho into L upon A. What is rho? Resistivity. L is what? L is a length. Length of what part? Length of the wire A to J. And what is A? A is the cross section area of this wire. Okay. If this is the wire, then this area will be the cross section area. Now, see, current remains constant because I am not changing the resistance of the primary circuit. The current remains constant. The thickness of the wire remains constant, even I am not changing that. In between the experiment, I am also not changing the material of the wire. So resistivity remains same. So what I can say? That potential difference between any 2 points is equal to some constant. See, this entire thing comes as the constant. Is directly proportional to length. V is equals to KL, or I can say V is equals to L. Got it? This is circuit of potentiometer, and by this method we can find the EMF. Sorry, we cannot find the EMF. What we can only find is that EMF or potential difference is directly proportional to length. EMF is directly proportional to length of this wire. Okay. Now, potentiometer is a practical topic. You will have to think in practical terms. People are coming out with specific methods to measure the potential difference or to compare potential difference. But you have to understand it, you have to go through your books, and if you are having problems in this, you always have somebody to which you can ask your problems, and that is me.